Listen carefully, because what I'm about to tell you might fundamentally change how you view our place in the universe. On October 29th, 2025, something happened that has left even the most skeptical scientists at Harvard speechless. The ALMA telescope detected something that shouldn't be possible, an object moving through space in a way that defies the laws of physics as we know them. But here's what's truly disturbing. This object, designated 3I Atlas, was 4 arc seconds off from where it should have been. That might sound insignificant, but in the vast emptiness of space, that's like finding your car has moved 3 blocks while you were sleeping. Something pushed it, something we can't explain. And the implications are keeping NASA scientists awake at night. We're not talking about a normal comet here. When the Solar and Heliospheric Observatory, along with Stereo and GOES 19, all captured the same impossible phenomenon, this object becoming bluer than our own sun, we entered uncharted territory. This is now the 9th official anomaly associated with this visitor from beyond our solar system. 9 things that shouldn't happen, but did. Let me put this in perspective for you. If 3I Atlas were behaving like any comet we've studied in the past century, it would need to have lost 15% of its total mass to achieve the acceleration we're seeing. That's over 5 billion tons of material. Imagine the weight of 50,000 aircraft carriers. That should be floating around it in a massive debris cloud. But here's the thing that's making scientists question everything. We can't find that cloud. December 19th, 2025. Mark that date. That's when 3I Atlas makes its closest approach to Earth. If we don't detect the debris cloud that physics says must be there, we'll be facing the 10th anomaly, an object that accelerates without losing mass. And that, my friends, would mean we're looking at something that operates outside our understanding of natural celestial mechanics. Professor Avi Loeb from Harvard, one of the most respected astrophysicists on the planet, has gone on record saying we need to seriously consider possibilities we've never had to consider before. He's not saying it's aliens, but he's not saying it isn't either. When you have this many anomalies stacking up, when the math doesn't work, when our most fundamental assumptions about how objects move through space are being challenged, you have to ask the uncomfortable questions. Let's go back to the beginning, because this story is unlike anything we've encountered before. 3I/ATLAS is only the 3rd confirmed interstellar object we've detected entering our solar system. The first was Oumuamua in 2017. That bizarre tumbling object that accelerated as it left our solar system without showing any signs of outgassing. The second was Comet Borisov in 2019, which at least looked and behaved somewhat like a normal comet. 3I Atlas. It's rewriting every rule in the book. The sheer size of this thing is staggering. We're talking about an object that's 1,000,000 times more massive than Oumuamua. Let me help you visualize that. If Oumuamua were a ping pong ball, 3I Atlas would be a multi-story building. It's also 1,000 times larger than Borisov. Yet despite this enormous size, it's moving faster than both of its predecessors. The statistical probability of finding an object that's simultaneously the largest and fastest interstellar visitor, less than 0.1%. That's like finding someone who's both the tallest person in the world and the fastest Olympic sprinter. Now let's talk about these anomalies, because each one alone would be remarkable, but together they paint a picture that's making even the most conservative scientists uncomfortable. The first anomaly is the trajectory. 3I Atlas is moving in a retrograde orbit, opposite to the direction of all the planets in our solar system. That's unusual but not impossible. What is nearly impossible is that this retrograde trajectory is aligned within just 5 degrees of our solar system's ecliptic plane. Imagine someone shooting a basketball backwards, blindfolded, from half court, and having it go perfectly through the center of the hoop. The probability of this happening naturally is 0.2%. That's 2 in 1,000. The second anomaly completely shattered our understanding of cometary behavior. Between July and August 2025, 3I/ATLAS developed something we've never seen before, a jet pointing directly toward our sun. This is the exact opposite of what should happen. When comets approach the sun, solar radiation vaporizes their ice, creating tails that always point away from the sun, pushed by solar wind. It's one of the most basic principles of cometary physics, but 3I Atlas created what we're calling an anti-tail, a jet aimed straight at our star. It's like watching water flow uphill. The third anomaly involves the impossible combination of size and speed. In nature, larger objects typically move slower due to conservation of energy. It's basic physics, the same reason a freight train can't accelerate like a sports car. Yet 3I Atlas breaks this rule completely. The probability of an object being both this massive and this fast, less than 0.1%. But the fourth anomaly might be the most statistically impossible of all. 3I Atlas arrived at the perfect moment to pass within tens of millions of kilometers of Mars, Venus, and Jupiter, while simultaneously becoming completely invisible from Earth during its perihelion, its closest approach to the Sun. The timing is so precise, it's like throwing 3 darts at 3 different moving targets, while someone turns off the lights at the exact moment you release them. The probability, 0.005%. That's 5 in 100,000. The fifth anomaly emerged from spectroscopic analysis, and it's forcing us to reconsider everything we know about solar system formation. 3I Atlas has a nickel-to-iron ratio unlike any natural comet we've studied. Even more disturbing, this ratio closely resembles the metallic alloys we produce industrially here on Earth. Natural comets have specific, predictable metal proportions that reflect the primordial composition of their parent solar system. 3I/ATLAS completely breaks this pattern. The probability of this occurring naturally, less than 1%. The sixth anomaly challenges our basic definition of what a comet is. Comets are essentially dirty snowballs. Most of their mass should be water ice, but 3I Atlas contains only 4% water by mass. That's like finding an iceberg that's 96% rock. This is so unusual that if we discovered this object in our own solar system, we'd have to create an entirely new category for it. The seventh anomaly involves something called polarization, how light waves orient themselves when reflected off an object. When sunlight hits 3I/ATLAS and bounces back to our telescopes, it shows an extreme negative polarization pattern that's never been observed in any other comet, including Borisov, which we know is natural. It's as if 3I Atlas is twisting light in a way that known natural materials simply cannot do. The probability, less than 1%. The eighth anomaly sends chills down my spine every time I think about it. 3I Atlas came from a direction that coincides within just 9 degrees of the origin of the famous WOW signal, that mysterious radio transmission detected in 1977 that many consider the best candidate for extraterrestrial communication ever recorded. 9 degrees might sound like a lot, but in the context of interstellar space, it's like 2 cars passing through the same intersection, just minutes apart. The probability of this being coincidence, 0.6%. The ninth anomaly was discovered just recently, and it's perhaps the most visually striking. Near perihelion, 3I Atlas didn't just brighten, it brightened more intensely than any known comet and became bluer than our sun itself. This is physically very difficult to explain with normal cometary materials. Our sun's surface temperature is about 5,778 Kelvin. 3I Atlas appear bluer It would need to be emitting light at even higher energy wavelengths, suggesting temperatures or processes we don't understand. And now we're waiting for what could be the 10th anomaly. The non-gravitational acceleration detected by ALMA should have required the loss of at least 5 billion tons of material. That's not something you can hide. It would create a debris cloud visible to every major telescope on Earth. But as our most sensitive instruments scan the space around 3I/ATLAS, they're finding nothing. No massive cloud, no debris field, just an object accelerating through space as if pushed by an invisible hand. Professor Loeb isn't pulling any punches in his assessment. He's applying the same scientific rigor that led him to become chair of Harvard's astronomy department. When you have data that doesn't fit existing theories, he argues, you must consider new hypotheses, however extraordinary they may be. He reminds us that Galileo was ridiculed for suggesting Earth orbited the Sun. Einstein's theories were initially dismissed as fantasy. The greatest breakthroughs in science often come from those willing to challenge established paradigms. What's remarkable is that Loeb is simply following the scientific method. He's presenting data, calculating probabilities, and saying we need more evidence to reach definitive conclusions. But the data we have is pointing in a direction that makes many scientists uncomfortable. If even one of these anomalies is confirmed as non-natural, we're looking at the most significant discovery in human history. The global response to 3I Atlas has been unprecedented. This isn't just NASA or the European Space Agency. This is every major observatory on the planet working in concert. The moment its interstellar nature was confirmed, telescope schedules worldwide were reorganized. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, the Subaru Telescope in Japan, all have turned their instruments toward this mysterious visitor. But it's not just about pointing telescopes at the sky. The computational challenge alone is staggering. 3I Atlas is moving so fast that keeping it in view requires constant recalculation of its position. Teams of scientists are working around the clock, updating orbital models, refining predictions, ensuring that our instruments stay locked on target. It's like trying to photograph a bullet in flight, except the bullet is millions of kilometers away and moving at 60 kilometers per second. The recent observations have added even more mysteries to unravel. Gravitational lensing, the bending of light by our sun's gravity, should affect how we see 3I Atlas as it passes close to our star. Loeb's calculations show a predicted deflection of 0.27 arc-seconds. It's tiny, but measurable with our most precise instruments. If the actual deflection doesn't match the prediction, it could indicate that 3I/ATLAS has properties we don't understand. Perhaps a density or mass distribution unlike any known object. Let me explain why the December 19th close approach is so critical. At that point, 3I Atlas will be just tens of millions of kilometers from Earth. Cosmically speaking, that's right in our backyard. Our telescopes will have their best opportunity to detect any debris cloud, to measure the object's exact dimensions, to analyze its rotation, to search for any signs of artificial structure. Every major observatory will be watching, every sensor will be recording. If there are answers to be found, that's when we'll find them. But here's what keeps me awake at night. What if we don't find a debris cloud? What if this object continues to accelerate without any visible means of propulsion? What if the 10th anomaly is confirmed? We'll be faced with three possibilities, each more extraordinary than the last. The first possibility is that we're seeing some entirely new type of natural phenomenon, a class of object that forms under conditions we've never encountered or imagined. Perhaps in some distant solar system, under exotic circumstances, nature can create comets that behave in ways that seem impossible to us. This would still be a revolutionary discovery, forcing us to rewrite textbooks and reconsider our models of planetary formation. The second possibility is that 3I/ATLAS has been modified or influenced by some unknown natural process during its billions of years traveling through interstellar space. Perhaps interactions with cosmic rays, or passage through dense molecular clouds, or close encounters with other stars have altered it in ways we don't understand. This would open entirely new fields of study about how objects change during interstellar journeys. The third possibility, and I say this as a scientist who deals in facts and evidence, is that 3I Atlas is not entirely natural. That somewhere, perhaps billions of years ago, an intelligence we cannot imagine created or modified this object. Whether as a probe, a beacon, or something else entirely, we must at least consider the possibility that we're looking at technology. I know how that sounds. Believe me, I understand the weight of even suggesting such a thing. But science isn't about what makes us comfortable. It's about following the evidence wherever it leads. And right now, the evidence is leading us into uncharted territory. The timing of 3I/ATLAS's appearance in our solar system adds another layer to the mystery. We've only had the technology to detect interstellar objects for a few decades. The odds of 3 such objects passing through during this tiny window of human technological capability should be astronomically small, unless, of course, interstellar space is far more crowded than we ever imagined. Current models suggest there could be trillions of interstellar objects passing through our galaxy at any given moment. Most are too small or too distant to detect, but if that's true, it means space between the stars isn't empty. It's filled with wanderers, each carrying secrets from distant solar systems. 3I Atlas might be just one messenger among countless others, but it's the one we happen to catch. The chemical composition continues to baffle scientists. That extreme carbon dioxide to water ratio, 8:1, suggests formation in a region where carbon dioxide ice was more stable than water ice. This could only happen at very specific distances from a star, in conditions completely different from our own solar system's formation. Any planets forming in such a system would have fundamentally different chemistry. Their atmospheres would be carbon dioxide rich from the start. The potential for life as we know it would be virtually zero, yet the potential for forms of chemistry we've never considered would be enormous. The presence of metallic nickel adds another puzzle piece. Nickel requires temperatures above 1,400 degrees Celsius to vaporize. Finding it in the coma of 3I Atlas means this object either formed in an incredibly hot environment or experienced extreme heating at some point in its history. But how do you reconcile that with all the frozen gases it contains? It's like finding ice cubes that survived inside a blast furnace. Some scientists have proposed that 3I Atlas might have formed in a binary star system, where complex gravitational interactions could have sent it careening between hot and cold regions, accumulating this bizarre mix of materials. Others suggest it might be a fragment from a planetary collision, a chunk of a world that was destroyed billions of years ago. Each theory has merit, but none fully explains all the anomalies. The anti-tail phenomenon continues to defy explanation. We've run computer simulations, we've reviewed the data countless times, we've checked for instrument error. The conclusion remains the same. For a period in July and August 2025, 3I Atlas produced a jet of material aimed directly at our sun. This isn't just unusual. According to our understanding of physics, it should be impossible. Solar radiation pressure always pushes material away from the sun. Always, except apparently when it doesn't. One hypothesis is that the implications extend far beyond just this one object. The object's age adds another dimension to consider. If it's really 3 to 11 billion years old, as trajectory analysis suggests, then it formed when the universe was much younger. The first stars were still shining. Many of the elements we take for granted didn't exist in large quantities. The galaxy was a different place entirely. The scientific papers being written about 3I Atlas already number in the hundreds, and we're just getting started. Each research team is focusing on different aspects: the chemistry, the dynamics, the origins, the implications. Graduate students are building entire careers on this single object. Conferences are being organized. New instruments are being designed specifically to study future interstellar visitors. But perhaps the most profound impact is philosophical. For all of human history, we've been isolated on Earth, only able to study our own cosmic neighborhood. Now, these interstellar visitors are bringing pieces of other solar systems to us. We're no longer limited to our own backyard. The entire galaxy is coming to visit, one object at a time. The way 3I/ATLAS reflects light is unlike anything in our databases. When we analyze the spectrum, the rainbow of colors in the reflected sunlight, we see absorption lines that don't match any known mineral or ice. It's as if this object is made of materials that don't exist in our solar system, or at least not in any combination we've encountered. Some researchers have suggested that billions of years of cosmic ray exposure might have created exotic materials on 3I Atlas, perhaps complex polymers or even metallic hydrogen under conditions we can't replicate. Others wonder if we're seeing materials that formed under pressures and temperatures only possible in the chaos of a forming solar system unlike our own. The lack of water ice remains one of the most puzzling aspects. In our solar system, beyond the snow line where water can freeze, every comet is dominated by water ice. It's so consistent that we've built our entire model of solar system formation around it. But 3I Atlas shows us that other solar systems might have completely different snow lines, different chemistry, different rules. If comets delivered water to early Earth, as many scientists believe, then a solar system bombarded by carbon dioxide-rich comets like 3I Atlas evolved completely differently. Instead of oceans of water, you might have seas of liquid carbon dioxide under high pressure. The atmosphere would be dense with greenhouse gases from the start. Any chemistry, any potential for life would follow completely different pathways. The precision required to track 3I/ATLAS has pushed our technology to its limits. The object is moving so fast that during a typical long exposure photograph, it would appear as a streak rather than a point. Special techniques had to be developed to stack multiple short exposures, compensating for the motion. It's like trying to photograph a race car by taking 1,000 pictures and combining them perfectly. As I record this, 3I Atlas is hurtling toward its close encounter with the Sun. Every day brings new observations, new data, new questions. The scientific community is electric with anticipation. Will the object survive the intense solar heating? Will new types of ice begin sublimating? Will we finally see the debris cloud that physics says should be there? There's also the tantalizing possibility that close examination might reveal surface features, impact craters, geological structures, or something else. Our best telescopes, working at their maximum resolution, might be able to detect details just a few meters across. If there's anything unusual about 3I/ATLAS's structure, December 19th is when we'll see it. The coordination required for this observation campaign is staggering. Time on the world's best telescopes is precious, usually scheduled months or years in advance. But for 3I Atlas, normal rules have been suspended. This is a once-in-a-lifetime opportunity, possibly a once-in-a-civilization opportunity. No one wants to be the observatory that missed the most important discovery in human history because they were looking at something else. Even the military and intelligence communities are involved. Satellites designed to track ballistic missiles and space debris have been retasked to observe 3I Atlas. Radio telescopes normally used for deep space communication are listening for any signals. If this object is transmitting anything, intentionally or unintentionally, we want to hear it. The possibility that 3I Atlas might fragment as it approaches the Sun adds urgency to every observation. Comets sometimes break apart under solar stress, and if that happens, we'd get an unprecedented look at its interior. Fresh surfaces would be exposed, pristine ices would sublimate for the first time in billions of years. It would be like watching a cosmic autopsy, revealing secrets hidden since before our solar system existed. But fragmentation would also mean losing our chance to study 3I/ATLAS as a complete object. The pieces would drift apart, each following slightly different trajectories, making detailed study much more difficult. It's a race against time and physics. The role of amateur astronomers shouldn't be overlooked. Around the world, thousands of dedicated observers with backyard telescopes are contributing observations. While they can't match the resolution of professional observatories, they provide continuous coverage that helps track any sudden changes. Several amateur astronomers have already received recognition for capturing important moments in 3I Atlas. As we've studied 3I Atlas, we've also had to confront our own biases and assumptions. We've realized how Earth-centric our view of the universe has been. We assumed all solar systems formed like ours, all comets behaved like ours, all chemistry followed patterns we're familiar with. 3I Atlas is forcing us to think bigger, to imagine possibilities we never considered. This humility is perhaps the most important lesson. The universe is under no obligation to conform to our expectations. Every anomaly, every impossible observation, every violation of what we thought were universal rules, they're all reminders that we're still children when it comes to understanding the cosmos. The debate within the scientific community is intense but respectful. Those who favor natural explanations point to the vast diversity of conditions in the universe, arguing that given billions of stars and billions of years, even the most unlikely objects will occasionally form. Those open to artificial possibilities note that the anomalies keep piling up, each one requiring increasingly complex natural explanations. What everyone agrees on is that 3I/ATLAS is extraordinary. Whether it's a natural wonder that expands our understanding of physics or something more exotic, it's already changed how we view the universe. The textbooks being written today will have a chapter on 3I Atlas. Students decades from now will learn about the object that challenged everything we thought we knew. As Brian Cox, I've spent my career trying to convey the wonder and mystery of the universe. But 3I Atlas reminds me that the universe is far more wonderful and mysterious than even I imagined. Every answer we find leads to 10 new questions. Every observation reveals new impossibilities. This is science at its most exciting, not the recitation of known facts, but the discovery of new truths that challenge our most basic assumptions. The coming weeks will be crucial as 3I Atlas swings around the Sun and begins its journey back to interstellar space. We'll have our last chances to study it. Every telescope will be watching, every sensor will be recording, the entire planet will be holding its breath, waiting to see what this cosmic visitor reveals. Will we find the missing debris cloud? Will new anomalies emerge? Will we finally understand what 3I Atlas and where it came from? Or will it leave us with more questions than answers, a cosmic riddle that future generations will have to solve? Whatever happens, one thing is certain. We're witnessing history. This moment, this discovery, This mystery will be remembered as a turning point in human understanding of the cosmos. We're not just observing a comet or investigating an anomaly, we're potentially making first contact with evidence of something beyond our solar system, beyond our current understanding, beyond our wildest dreams. The universe has sent us a messenger, wrapped in ice and mystery, traveling for billions of years to reach us at exactly this moment in human history. What that message is, we're still trying to decode, but the fact that it exists at all tells us something profound. We are not alone in receiving these cosmic postcards. The universe is full of wonders we haven't even imagined yet. So keep watching the skies, follow the updates as December 19th approaches. Be part of this historic moment, because whether 3i Atlas turns out to be a natural marvel or something more, it's already shown us that the universe is far stranger, far more interesting, and far more mysterious than we ever dared to imagine. Check out the suggested videos on your screen for more incredible space discoveries and cosmic mysteries. The universe is speaking to us. We just need to learn how to listen.